So now in this video we'll put everything that we've discussed together in solving problems related to probability. So just quickly, any normal distribution can be converted to its standard normal distribution. So if we are trying to find the probability of an event in the regular normal distribution, then we change the problem to finding the probability of an event to its corresponding event in the standard normal distribution, and that gives us the answer to the question, what is the probability of a certain event in the regular normal distribution? So let's look at a certain normal distribution with mean 13.4 and standard deviation 1.2. So what is the probability that x is less than 14.2? So remember that x is the variable in the regular normal distribution, but now we'd have to standardize it and change it to its value in the z distribution. So this is our x value, and that also has to be changed to its z value, and the formula that is used is x minus mu divided by sigma. So x is 14.2 minus 13.4, which is the mean, divided by standard deviation 1.2. When I simplify, I get 0.67. So basically what this says is probability that x is less than 14.2 is the same as saying that z is less than 0.67. So finding the probability that z is less than 0.67 can be solved by looking at the table of probabilities or areas, which is table B. So we identify the 0.67, which is 0.6, and then we move to the right until we get the number corresponding, or the table entry corresponding to 0.07. So this would be the area to the left of 0.67. So the area to the left of 0.67 is 0.7486, and that would be the probability that x is less than 14.2. Now let's look at the probability that x is greater than, notice this is greater than 10.75. So what's the first thing we do? We have to standardize the x. So x becomes z, and 10.75 can be converted to its standard value by taking x minus mu divided by sigma. So 10.75 is the x, minus mu, which is the mean 13.4, the whole divided by 1.2. So that's negative 2.65 divided by 1.2, which is negative 2.21. So the area, so probability that z is greater than negative 2.21 is the same as the area to the right of negative 2.21. Remember that the table gives us the area to the left of negative 2.21, or to the left of any z value. So the area to the right of it would be just 1 minus the area to the left of it. So the area to the left of negative 2.21 is 0.0126. We subtract that from 1 to get 0.9874, and that would be the area to the left of negative 2.21. So whenever we try to find the areas, it's best to draw the standard normal distribution and shade the area. So when we get the area finally, we can look at the shaded area and kind of visually confirm that the answer is correct and it's not completely off. Here is a problem where we have to find the probability of a certain event in a normal distribution. Notice that it's a normal distribution with 400, the first number being mu, and the second number being the standard deviation sigma. So what we are measuring here is the a woman's bladder volume given in milliliters. So if we calculate the women's bladder volumes, then the distribution is bell-shaped with center 400 and standard deviation 75. We need to find the probability that, or proportion that, a woman's bladder volume lies between 500 ml and 600 ml. Always the smaller number is to the extreme left and the larger number is to the right, and X sits in the middle when we talk about measurements between two numbers. So the probability that X is the woman's bladder volume, lies between 500 ml and 600 ml is what we need to figure out. So probability is equal to area, but this is the regular normal distribution. We need to first standardize it. So write down your mean and standard deviation. We next write down the probability that we need to figure out. This is an important part of solving the problem, writing down in mathematical symbols the probability that we are trying to figure out. The next thing is standardizing using the formula x minus mu divided by sigma. So x minus mu divided by sigma becomes the z value of what we are trying to find. So that is, if it's the z value of 500, it would be 500 minus mu, so minus 400, which is the mu, divided by sigma, which is 75 ml. And that's how we standardize the x value. So remember to change the x to z because we're converting everything to its z value. So the z value of 600 ml would be 600 minus mu, which is 400, divided by sigma, which is 75. Use your calculators to simplify. So finding the probability that a woman's bladder size lies between 500 ml and 600 ml is the same as finding the probability that z lies between 1.33 and 2.67. Now all we have to do is go to the table and find the area that lies between 1.33 and 2.67. So let's shade the area first. Draw a little sketch. Notice that it goes from 0 to 3 on the right, -1, 0 to -3 on the left. And the area that we need is the area from 1.33 to 2.67, and that's the tiny area that we're trying to figure out. So finding the area between two z values, we take the area to the left of the larger z value minus the area to the left of the smaller z value, and we can determine both from the table B. Do the subtraction, and that gives you the area sandwiched between these two z values, and that is equal to 0.088. So what we can conclude is the probability that a woman's bladder volume is between 500 and 600 ml is 0.088. So it's the same problem. The measurement X is the woman's bladder volume, and we've seen that mu is equal to 400 and milliliters, and sigma, which is the standard deviation, is equal to 75 milliliters. So that's been given to us. Now we're trying to find the probability, so that's P of that a woman's bladder volume, which is X, is greater than, so use the symbol greater than, 350 milliliters. So that's what we're trying to figure out. So probability that X is greater than 350 ml. Now we have to change everything to the standard units. So X changes to Z. 350 ml can be changed to its Z value by using the formula X minus mu divided by sigma. So that's 350 which is your x, minus 400 divided by sigma, which is 75, is equal to negative 0.67 if we use the calculator. So we're trying to find the probability that z is greater than negative 0.67. So that would be the area to the right of negative 0.67. So the total area 1 minus the area to the left of negative 0.67, which can be obtained from table B, and it's equal to 0.2514, and that's equal to 0.7486. So when we look at the sketch, does it make sense that the area would be 0.7486? Because if you're way off, at least you'll see that when you compare the area that you get, which is the probability, in the area that you've sketched.